So good evening everyone and welcome to this lecture on electrostatics. And we'll go through this part pretty quickly. Most of the things that you must know. The first thing that we are going to understand is what do you mean by an electric charge. You don't have to note it down. You just, if you know it, just mark it. What do you mean by electric charge? When I talk about electric charge, I mean the property. It is one of the inherent property of a body by virtue of which the body will experience electrostatic or magnetic forces. Do we understand this? So basically your electric field is that electric charge is that property by virtue of which it experiences electrostatic or electric and magnetic field. Do we understand this? Yes or no? You must know this, right? Now when you
Yes,
talk
sir.
about this electric charge, there are certain properties of the electric charge that you must remember. You must be knowing these properties. Do we know these properties? Yes or no? Properties of electric charge. You must have written them. You can just note down if you have missed any point. The first is charge is a scalar quantity. Do we understand this? Charge is a scalar quantity.
Yes, sir.
When I say a body is charged, when I say a body is neutral, that does not mean that it does not have charge. It has charge, but the amount of positive and the negative charge is equal. Do we understand this? An atom is electrically neutral. I hope you must have heard about this. We have found out different type of fundamental particles, protons, electrons, and neutrons. And we have seen, or we know, that the charge of a proton is taken as positive. Remember, it's a convention that we follow. Proton charge is positive, electron charge is negative, and neutrons do not have any charge. Now, normally an atom is electrically neutral. When I say electrically neutral, what it actually means is the number of positive charge proton and number of negative charge electrons are equal. If you can create an imbalance, if you can remove electrons from the atom, negative charge becomes less, positive charge remains the same, the body becomes positively charged. We can add or subtract charge just like numbers. If one charge is removed, it becomes one positive charge. If two charges are removed, it becomes two times positive charge. Therefore, charge is a scalar quantity. There are two types of charges that we know. One is positive charge. One is called positive. The other one is called negative. Remember, this positive and negative are way of differentiating them. We could have called them Ram and Sham, Sita or Gita, but we started calling them positive or negative. Positive and negative does not mean that one is more powerful than the other. They are just different type of charges. We have named positive and negative is just a name. Do we understand this? Charge
Yes,
can be created, charge is always conserved. If I lose 2 electrons, someone will get 2 electrons. If I lose 2 electrons, I will get positively charged. If he gains 2 electrons, he will get negatively charged. The net charge of the system remains constant. Do you understand this?
yes, sir.
I hope you have noted down all these properties before. Now, the next property is that the charge is quantized. Do you know what do you mean by charge is quantized? Charge comes in packets.
Packet.
And the smallest packet of charge is a charge of an electron or charge of a proton. Particle theory of light, the photoelectric theory of light suggests that light also comes in packets, and the smallest packet of light is photon, smallest packet of charge is electron or the charge of a proton. Like charges repel each other, unlike charges attract each other. Do we understand this?
Yes, sir.
So that is the next property that you must remember. I hope that you know all these properties, because there could be a question which might come for you from this theory part of charge. Like charges repel each other, unlike charges attract each other. All of you must know this. Next point, and it is very important point. Charge is always associated with mass, but mass may not be associated with charge. If something has charge, must have mass. Charge comes from either electrons or protons. Electrons also have charge, protons also have charge. So charge must come from mass, but mass may not come with charge. Neutron, if you only have neutrons in a body, it will have only mass but no charge. Do we understand this? Next thing is known as it is relativistically invariant. That means with any velocity a charge is moving, or you are moving with any velocity, the value of charge will always remain same. The value of charge does not depend on its speed. Do we understand this? If you are moving too fast, your mass also changes, but the charge will not change. Do we understand this? Yes or no?
Yes, sir.
The name of this chapter is Electrostatics. That means we are going to study charges at rest. What it actually means is we are going to study the field which is produced by charges which are at rest. When the charges are at rest, my dear friends, they produce electrostatic fields. When the charges are moving with a constant velocity, they produce electrostatic as well as magnetic field. And when the charge is accelerated, it also emits radiation, and we will see all these three quantities. And the last one we will see in the last chapter, which will be known as electromagnetic waves. So this chapter, this discussion will end where? With the last chapter, which is electromagnetic waves, where you will get this condition, the third condition. It gives energy. In this chapter, we are going to study this one, the charges at rest. In the next chapter, magnetic field, we are going to move charges, so they are going to produce magnetic field. In the last chapter, we will see charges accelerating, and therefore they will give out radiations, electromagnetic radiations, EM waves. Do we understand this, or this has gone above our heads? Saying bye-bye. I'm going, don't worry about me. Understood this? Yes or no?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay. Now, you must understand how you can charge a body. How can you charge a body? How you can give charge to a body, or how can you charge a body? To charge a body, basically what you need to do is you need to transfer the electrons from one body to the other body. Yes or no?
Yes, sir.
If you can do that, you can charge a body. So the first way of charging a body is by friction. You may not note down everything. You must know this. There are only three ways of charging a body. Charging by friction, you rub things. If the electrons get sufficient energy, photoelectric effect, electrons get energy by light. X-rays, electrons fall, X-rays are emitted. You rub things, electrons may get energy, and they may get transferred. This is known as charging by friction. Do we understand this?
Yes, sir.
Then the second way in which you can charge is charging by induction. So if you bring a charged body near to an uncharged body, you can actually induce charge on that uncharged body without even touching it. Do we know this? Yes or no? Huh?
Yes, sir.
Have you heard this? Charging by induction? Yes or no, beta?
Yes, sir.
Charging by induction. So you can see you bring a charged body near an uncharged body. If you bring a positively charged body, it will attract the negative charge, and positive charge will go on the other side. If you can remove the positive charge on the other side, the body becomes negatively charged. Do you see this? This is known as charging by electrostatic induction, my dear friends. You all understand this? Yes or no? Then we have the third method of charging, my dear friends, which is known as what? It's known as what? Charging by friction, charging by induction. What is the third way of charging things? Charging a body, huh? No one knows it. It is charging by conduction. You bring you bring two bodies in contact. One is charged, other one is uncharged, and then you can see these things happen. Do you understand? By the diagram, what is happening? Huh?
Yes, sir.
And that is why this diagram is given, so that you understand the charging process. You understand this?
Yes, sir.
Yes, sir.
Good. Now this is a very famous question that comes in exam many times. Give me the answer so that we can move ahead. Soap bubble is given negative charge. Its radius will no idea. Increase, decrease, remain, change, fluctuate. Hui. It will increase. Why will it increase? Why will it increase? You give it negative charge, my dear friends. Because of the repulsion of the charges, the radius will increase. Do we understand this?
Yes, sir.
Yes or no? Okay. Next one. Which of the following values of charge is not possible? Huh? These are the questions that are going to come in the exam, bacha.
Option C, sir.
Why option C, sir? There must be a reason behind it. Huh? No one knows the reason, but you know the answer. The smallest. Yes, Abhiram, that is correct. Charges are integral multiples. Charge are quantized. They are integral multiples of charge of an electron. The smallest packet is charge of an electron. And the smallest packet is 1.6 into 10 raised to the power minus 19 Coulomb. The smallest amount of money that you can probably have these days is 1 rupee. If someone asks you, give me 50 paisa, how will you give it? You would cut 1 rupee and give low. Take. Don't have 50 paisa these days, probably still applicable in West Bengal. When I was there in West Bengal, even 5 paisa was sellable. But rest of India, 1 rupee. Someone can't give you 0.1 rupee because he cannot cut 1 rupee into 10 parts and give you 1 part. Take it. The smallest packet. Now 1.6 into 10 to the power minus 18 is 10 times. So you have 10 electrons. That is why the charge is this. 1.6 into 10 to the power minus 19 is 1 electron. But 1.6 into 10 to the power minus 20 will be 1 by 10 of an electron, which is not possible in this universe, bacha, because this is the smallest packet that we have. Do we understand this, or this is going about what I'm saying? Bye bye. I'm going. Don't worry about me.
Understood, sir.
Next one. This one, since remember, you are going to get simple questions on this. If the radius of a solid and a hollow copper sphere are same, which one can hold greater charge? Remember, there is a property of charge that you must know, that for a conductor, charge is always on the outer surface of the conductor. Whenever you charge a conductor, the charge comes on the outer surface. Having said that, what is the answer for this one, my dear friends? Right? These are the type of questions that are going to come, bacha. Give me the answer, fatapat. Man, no one knows the answer. I'll give you 1 minute to do it.
Sir,
Yes, beta.
I guess option C.
Why are you guessing? Why are you not confident about the option C? It is option C.
Because radius of both the spheres will be equal.
The surface areas are equal. Charge on a conductor only comes on the surface of the conductor. Whether it is hollow, whether it is solid, doesn't matter. Charge will come on the outer surface. Both have the same radius. Therefore, the answer is C. Both will get equal charge. I hope you understand this. Yes or no?
Yes, sir.
Next one, do it fatafat. We don't have time. If you don't do it fatafat, I will have to skip questions. I don't want to skip them. So do it fast. This is the next question. See, we are only concentrating on the question that are going to come in your exam. I have the entire paper with me, and I know from my previous experience whatever question are likely to come. This one. You have 2 minutes to do it. Do it fast. Remember, JEE or NEET, it's not cleared in the examination hall. No, my dear friend. No. You don't clear JEE or NEET in the examination hall. You clear it in the class by doing questions. And then you do so many questions that you are sure that one of the questions that you have done will come and you will be able to do it. That is what students do. Do so many questions that you're confident that one of the question is going to land up in the examination hall. Yes. Number of electrons in 1 coulomb of charge. Huh? Don't know this?
Sir, option C.
Sir, option C, are you telling me or are you asking me? I don't know. I will have to look at the answer. And the answer is option B. Not C. Number of electrons in 1 coulomb of charge. Hey, Bhagwan. How you do this? Total charge, right? Total charge will be n times the number of electrons. So the number of electrons or number of charge will be Q divided by charge of an electron, bacha. 1.6, right? This is 1 coulomb. So this is 1 divided by 1.6 into 10 raised to the power minus 19. And once you divide it, bacha, remember the answer that you get is 6.25 into 10 raised to the power of 18. Remember this, don't forget this. We get this, yes or no? No, yes.
Yes, sir.
Okay, these are the questions that I have found from my experience that can come. The rest of the questions we can't do at this point in time because we have only just started. So now we move on to the next heading. And what is the next heading, my dear friends? Huh? What is the next heading? No one knows it? The next heading is Coulomb's law. Everyone remembers Coulomb's law? Yes or no?
Yes, sir.
Yes, sir.
What is Coulomb's law? So you must have done this. So I will just move quickly.
F is
Coulomb's
equals
law.
to K into Q1 into Q by R square.
Yes. Coulomb's law gives us the force of attraction or force of repulsion between two charges separated
Two
by a
charges.
distance r. Yes or no?
Yes, sir.
Coulomb's law gives us the force of attraction or repulsion between two charges. What does it say? This F is equal to K into Q1 into Q2 divided by R square. Now this K, remember, is a constant and it depends on the medium. Do we know this? This K is a constant, but it depends on the medium. Everyone knows this, yes or no? No or yes?
Yes, sir.
Yes, sir.
What is the value of K for vacuum, my dear friends? The value of K for vacuum
Into 10 to the power of minus 10.
can be written as 1 by 4 pi epsilon naught, and that will be equal to 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Yes or no?
Yes, sir.
Yes, sir.
This epsilon naught is again a constant, and this epsilon naught is known as absolute permittivity of free space or vacuum. Yes or no?
Yes, sir.
Yes, sir.
Absolute permittivity of free space, and the value of this is 8.85
10 to the power of minus
into
12.
10 raised to the power minus.
Minus 12. Minus 12.
Remember the units, Coulomb square per Newton meter square. It is the reverse of K. Do we understand this?
Yes, sir.
This is the value for electrostatic field in vacuum. What happens if it is a medium? So for in a medium, what happens? If we are trying to calculate the force in a medium, then what happens, my dear friends? Force in the medium becomes K in the medium into Q1, Q2 by R square. Now, what is the value of K in any medium, bacha? What is the value of K in any given medium? It is 1 by 4 pi epsilon naught into epsilon R. What is this epsilon R known as? This is known as relative permittivity of the medium. Do we understand this? Relative permittivity of the medium. We understand this. And
Yes, sir.
remember, it is a number. It has no unit or dimension. Will you remember this? Sometimes
sir.
this epsilon R is also known as K. This K is known as the dielectric constant. Do we understand this?
Yes, sir.
Everyone knows this, yes or no?
Yes, sir.
Now, in this medium, I can also write this K in the medium as 1 by 4 pi epsilon. Now, what is this epsilon known as? This is known as the permittivity of the medium. Do we understand this? Or absolute permittivity of the medium. Will you remember these things, yes or no?
Yes, sir.
Everyone?
Yes, sir.
Okay. Now remember, we have a vector formula for electrostatic force also. Have you noted this down?
Yes, sir.
We will not be using this vector formula, but you can just write the vector formula as well. Vector formula for Coulomb's law. What is the vector formula for Coulomb's law? Force on 1 due to charge 2 is equal to K Q1 Q2 divided by R cube into radius vector of 1 with respect to 2. You have to find out the vectors. You are not supposed to get any questions on this, so don't worry about this. Just write the formula. If they ask you the formula, you must know the formula. So just write it. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Then they can write some important points about them, about Coulomb's law. And remember, these important points are basically your questions that may come. The first point is this one. This formula KQ1 Q2 divided by R square is only applicable for point charges. Will you remember this?
Yes, sir.
Yes, sir.
Okay. The next thing that you must remember is that this is a force. So it also has a direction apart from the magnitude. What is the direction of this force? It always acts along the line joining the two charges. Do we know this? It is
Yes,
equal
sir.
in magnitude and opposite in direction on the two charges. Do we know this? Yes or no?
Yes, sir.
Anyone knows this?
Yes, sir.
Okay. I think this is enough for you to know. Can you move on to questions?
Yes, sir.
This is the first question that you must do. A particle of mass m carrying a charge q is revolving around another fixed charge minus q2 in the circular part of radius r. Calculate the period of revolution and the speed. I'll give you 2 minutes to do this. How will you find this out? Think. Think for 2 minutes. If you can't solve it, I will solve it. Don't worry. But think. Remember, it is a question. It's a question based on force between two charges. Nothing else, bacha. If you want any help, I'm always there to help you. Shall I do it? Or shall I wait? I'll give you 1 more minute. No one knows the answer.
Sir,
Yes?
2 pi by t, sir.
2 pi by t. You have to find the time period of revolution. What is given to you is the mass of the particle and the charge q1 and q2. And from there, you have to calculate this. You had covered this topic till Gauss law there, na? You had not done any question like this? Okay. So, see, it's a very simple question, beta. Just see it. How am I supposed to do this? So basically, this is the condition given here. A minus q2 charge is here and a plus q1 charge is moving with a velocity v. Yes or no? Now, when it is moving in this, there must be a force which is towards the centripetal force. Then only it can move in a circular path. Yes or no? The centripetal force is equal to mv square by r, the radius of the circle. Yes or no?
Yes, sir.
Now this centripetal force is provided by the force of attraction between the two. And what is the force of attraction? K into first charge q1 into second charge q2. Remember, even if it is a minus charge, I am not taking it as a minus charge. Minus and plus only tells us the type of charge, nothing else. So K into q1, oops, wrong color. K into q1, q2 divided by r square. From there, I can get the value of the speed of the particle, bacha. R and R getting cancelled. So I can get the speed of the particle as K into Q1, Q2 divided by M ka under root. Do we understand this?
Yes, sir.
That is the first thing. Now, we have to also find the time period of revolution beta, uniform circular motion. You might not remember it. Time to get the time period, you must find 2 pi by omega, yes or no?
Yes, sir.
And to get the omega value of omega, you divide v by r. You've already calculated the value of v beta. You can find the value of omega. You just divide this v by r. So it will be 1 by r into under root of k times q1, q2 by m. Do we get this? So your time period will become 2 pi divided by this. So 2 pi divided by this, you will get 2 pi r into root over m by k times q1, q2. Do we understand this, how I have done this?
Yes, sir.
Everyone got this? Okay. Now remember, this is probably the toughest question that you can get in this category. So don't worry. This is probably the toughest question that you can get. Since that was the only question that was possible, so that is why I gave you this question. Let us move on to the next thing, and the next thing is known as the principle of superposition. Do you know this principle of superposition? Principle of superposition of forces. We have seen this principle of superposition in waves chapter also. If I have one charge Q and it is experiencing a different forces F1, F2, F3, and so on. How will I find the net force on this particle? How will I find the net force on this particle, bacha?
F1 plus F2 plus F3.
So it will be summation of Fi. Do we understand this? This principle is known as the principle of superposition
Superposition.
of forces. Do we understand this? Yes or no?
Yes,
Yes,
sir.
sir.
Now, based on this principle of superposition, you should be able to find simple questions and answer to those simple questions. Can I give you some questions based on this principle of superposition?
Yes, sir.
Chalo. Let us start with some questions. Everyone has noted this down, yes or no?
Yes, sir.
Yes, sir.
Chalo, this is the first question. Let's see if you can do this one. Remember, simple questions are only going to come in your exam. This is the first question on Coulomb's law. Two point charges plus 3 microcoulomb and plus 8 microcoulomb repel each other with the force of 40 newtons. If a charge of minus 5 coulombs is added to each of them, what will be the force between them? 2 minutes you have. Yes, bacha. Shall I solve it for you? Give you time. 1 minute. I have sent the sheet of electrostatics. Did you get that sheet? Yes or no? I sent the sheet of electrostatics. I think you would be getting it. So once you get it, try and do problems from that sheet, as many as possible. Those are the type of problems that are going to come in your exam. Shall I do this one? Or are you still trying? Looks like you are trying. Process. I'm waiting patiently for your replies. Shall I wait or shall I give you the answer? Is it so difficult that you're not able to do this? What is difficult here? What is difficult here? Tell me, bacha, what you don't understand. What is difficult here? I think it's a pretty straightforward, simple question. Yes or no? So straightforward, simple question. Read the question carefully. R is not known to you. That is the only thing. But you can just cancel it from the previous one and you should get your answers. Think about it for 1 minute. And if you can't do it in that 1 minute, I will do it for you. It's a simple question. It's a simple question, straightforward question it is, bacha. The only thing is probably you have not done a question like this before. That might be the only thing that is troubling you.
Sir,
Yes, beta.
-20.
-20. No, that is not the answer. That is not the answer, but at least you are trying.
20.
Okay, I think I've given you enough time. If you're not able to comprehend this, probably I think I should help you out now. What is the problem with this question? Tell me what you're not able to understand.
F1 is equals to F2.
F1 is equal to F2. Same. No, it's not same. It's not coming same. How will it come same, bacha? Not come same. You're missing a point here. Everyone is missing a point. I think since you're not able to understand, and I would have to jump in. I did not want to do this question. I thought that you would be able to do this. It seems like you are out of practice in electrostatics. Is that so? Anyways, don't worry. We will become good in this. So, how are you supposed to do this? Yes. So, I hope you can see this. How are you supposed to do it? In the first case, let me call the force is given by K times Q1, Q2 by R square. In the first case, the force is one charge is 3, other charge is 8 multiplied by K divided by R square. Let me call this as F1. What will be the force in the second case, F2? I have given -5 Coulomb charge to this one. So this becomes 2 Coulomb with negative charge. So 2 multiplied by, I give plus 8 Coulomb minus 5 charge. It becomes 3. 2 into 3 multiplied by K divided by R square. I divide F1 by F2. F1 by F2. It becomes 1 by 4. So your F2 becomes, no, your F1 by F2 becomes 4. So your F2 becomes F1 by 4, 10 newtons. But remember, at present, previously they were repelling, but now one of them has become negative, so they're attracting. So the answer is -10. Why it was so difficult for you to do this? In first case, the charges are 3 and 8. In second case, I have added -5 Coulomb. So this 3 becomes -2. So the force becomes attractive. This 8 becomes +3. Was it so difficult for you to do this, beta? What were you doing? Chalo, Doesn't matter. We will do more questions of this in the next class. Meanwhile, what you can do is try questions from the sheet that I have given to you. Okay. Okay. I'll see you in the next class and we'll do more questions on this unless and until you become confident of doing questions and I am confident of you able to do this. I will not go ahead. So take care. I'll see you in the next class. God bless all of you. Bye bye.
Thank you, sir.